welcome to our deep dive. Today we're going to be tackling the quantum world.
Oh, the quantum world.
Yeah, and we're going to be using this fascinating report titled "The Quantum World: Unveiling the Universe's Mysteries." So get ready for some serious mind-bending concepts.
That's right. We're going to be talking about things like particles existing in multiple states at once.
Whoa.
And the universe, well, maybe operating on probability and even the possibility of parallel universes.
Okay, I am so ready for this. So maybe let's just start with the basics. What exactly is quantum mechanics? Like, how would you explain it to someone who's, not a physicist?
Well, you know how in our everyday world, things seem to follow these, pretty predictable rules, like what goes up must come down.
Right.
But when you zoom in, way in to the level of atoms and the particles within them, things start to get really, really weird. And that's where quantum mechanics comes in. It's the study of how things work at that super tiny level where the rules are completely different.
Okay, so it's like there's this whole other set of rules governing the universe that we just don't see in our everyday lives.
Exactly. And these rules lead to some really bizarre phenomena, like take superposition, for example.
Superposition.
Yeah, so imagine a single particle that can be in multiple states at the same time. It's like it's both a wave and a particle.
Oh, yeah.
Or it's spinning up A and D down simultaneously.
Hold on. It can be in multiple states at once.
At once, until we try to measure it. It's like flipping a coin and it landing on both heads A and D tails.
How is that even possible?
Well, that's the thing about quantum mechanics. It doesn't always make sense to our everyday intuition, but it's been proven time and time again through experiments. Another mind-boggling concept is entanglement.
Okay, entanglement. Let's hear it.
So imagine you have two particles that are linked in a way that defies distance. If you change the state of one particle, the other one instantly changes too, even if they're light years apart.
No way. So it's like they're communicating faster than the speed of light.
It almost seems that way, right? But it doesn't actually violate the laws of physics. It's more like they're connected by this invisible thread that transcends space and time.
Wow, that's just wild.
It is. And then there's the Heisenberg uncertainty principle, which says that you can't know both the position and momentum of a particle with perfect accuracy.
The more you know about one, the less you know about the other.
Exactly. It's like trying to pin down a buzzing fly. The more precisely you know where it is, the less you know about where it's going.
So it's not just a matter of our instruments not being good enough.
No, it's a fundamental limit to what we can know about the quantum world. It's built into the fabric of reality itself.
Okay, so we've got superposition, entanglement, and the uncertainty principle. These are some seriously heavy concepts. I think we need to take a step back for a second and talk about how we even got here. Like, how did scientists even start to uncover this strange quantum world?
Well, it all started with Max Planck.
Max Planck, okay.
Back in the early 1900s, he was studying black body radiation.
Black body radiation.
It's a theoretical object that absorbs all radiation incident upon it. Anyway, Planck discovered that energy isn't this smooth, continuous flow like we thought. It actually comes in these tiny packets called quanta, like discrete steps on a staircase.
So energy is quantized.
Exactly. And this was revolutionary because it implied that the universe wasn't as smooth and continuous as we previously thought. But Planck himself was initially hesitant to accept the full implications of his own findings. He wasn't quite ready to embrace the weirdness.
That's kind of funny, right? Like, the guy who discovered this revolutionary concept was a little bit afraid of what it meant.
Yeah, it was actually Einstein who took Planck's idea and ran with it.
Einstein.
Yeah.
Of course. He was always up for a challenge. So what did he do with it?
Well, he used the idea of quantized energy to explain the photoelectric effect.
The photoelectric effect. Remind me what that is again.
It's basically where light shining on a metal can cause electrons to be emitted. And the weird thing was that the energy of the electrons didn't depend on the intensity of the light, but on its frequency.
Okay.
And Einstein realized that this could be explained if light itself was also quantized, if light could behave as both a wave and a particle.
So light is like a chameleon. It can change its form.
It is. And this idea of wave-particle duality was huge. It opened up this whole new way of thinking about the nature of light and matter. And then along came Niels Bohr,
Niels Bohr, okay.
who incorporated this wave-particle duality into his model of the atom.
Right, the atom, the building block of everything.
Exactly. So Bohr proposed that electrons in an atom can only exist in specific energy levels, and that they can jump between these levels by absorbing or emitting photons of light, like a quantum leap.
So it's not like electrons are just orbiting the nucleus like planets around the sun.
No, no, it's much more complicated than that. It's more like they're occupying these fuzzy clouds of probability.
Okay, my head is already starting to spin a little bit.
Well, just wait, because it gets even more mind-bending. After Bohr, you had guys like Schrödinger and Heisenberg who came along and developed these mathematical frameworks.
It's Schrödinger, isn't that the cat guy?
Yeah, the thought experiment with the cat in the box.
Right.
He developed wave mechanics,
Oh.
and Heisenberg developed matrix mechanics. And these frameworks gave us a deeper understanding of the probabilistic nature of the quantum world.
Okay, so we've gone from quantized energy to wave-particle duality to a universe governed by probabilities.
Right.
It's a lot to take in.
It is, and we're just getting started.
Oh boy, I can't wait to hear more.
Yeah.
But before we dive any deeper, maybe we should take a quick break. We'll be right back with more of our deep dive into the quantum world.
So are you ready to dive back in?
I think so. My brain is definitely getting a workout.
Well, all this quantum weirdness we've been talking about, it's not just theoretical. It actually has real-world implications. Like, think about your smartphone.
My smartphone. What does my phone have to do with quantum mechanics?
Well, it's packed with transistors, tiny little switches that control the flow of electricity. And transistors rely on quantum mechanics to function.
Wait, so you're telling me my phone is a quantum device?
In a way, yes. And it's not just smartphones. Lasers, MRIs, even the way stars generate energy. All of these things rely on quantum phenomena. We're surrounded by quantum technology without even realizing it.
That's pretty amazing. I never thought about it that way. So quantum mechanics isn't just about this strange subatomic world. It's actually shaping our everyday lives in profound ways.
It is, but it also challenges our very understanding of reality. Like, let's think about the philosophical side of quantum mechanics for a second.
Okay, I'm ready for another mind-blowing session.
All right, so for centuries, classical physics presented us with this deterministic view of the universe, like a giant clockwork mechanism where everything was predictable.
Right.
But quantum mechanics throws a wrench in that whole idea. It introduces probability into the equation.
Probability. So you're saying the universe isn't as predictable as we thought, that things happen by chance?
It's more nuanced than that. But yeah, at the most fundamental level, the universe might not be so predetermined after all.
Okay, so we're not living in a clockwork universe, but maybe a cosmic casino.
That's an interesting way to put it. And this brings up another question, free will.
Right. If everything is just random chance, then do we really have any control over our own lives?
Well, that's a question that philosophers and physicists have been debating for decades. Quantum mechanics doesn't necessarily negate free will, but it does suggest that reality might be more fluid and less fixed than we previously thought.
I guess that's both liberating and a little terrifying at the same time.
It is. And speaking of mind-boggling concepts, let's talk about the observer effect.
Yes. The observer effect. Does that mean our consciousness can actually influence reality?
Well, it's one of the most debated aspects of quantum mechanics. Remember how we talked about superposition, where a particle can exist in multiple states at once?
Yeah.
The observer effect suggests that the act of observing or measuring a particle forces it to choose one state.
So it's like the particle is waiting for us to look at it before it decides what to be.
It's almost as if our consciousness is playing a role in collapsing the wave function, the mathematical description of the particle's state.
Whoa, hold on. Are we really saying that our minds can influence the physical world at the quantum level?
It's a mind-boggling idea, and it's still a subject of ongoing debate. There's no definitive answer yet, but it's fascinating to consider the possibility that our minds might be more entangled with the fabric of reality than we ever imagined.
Yeah, that's definitely a lot to wrap my head around. But while we're on the subject of mind-bending concepts, we have to talk about the multiverse. Is that a real possibility or just something from, comic books and science fiction?
Well, the multiverse is a theoretical concept that arises from some interpretations of quantum mechanics. It proposes that there might be countless other universes coexisting alongside our own, each representing a different outcome of quantum events, like Every time a quantum measurement is made, reality might branch off, creating a new universe.
So you're saying there's a universe out there where I made different choices,
Yeah.
where things turned out completely different.
It's a wild thought, isn't it? And while there's no direct experimental evidence for the multiverse yet, it's a concept that many physicists take seriously.
Wow, okay, now I really feel like I'm living in a science fiction novel.
I know, it's a lot to process, but I think it's important to remember that quantum mechanics is still a relatively young field. There's still so much we don't know, and that's what makes it so exciting.
Absolutely. And on that note, maybe it's a good time to step back and try to make sense of everything we've learned so far, because this is a lot to digest. All right, so we've covered a lot of ground. Superposition, entanglement, the uncertainty principle, the observer effect, even the multiverse.
It's a lot to take in, for sure, but I think it's all incredibly fascinating, don't you?
Absolutely. I mean, it really makes you question everything you thought you knew about reality.
Right. Like, we've been talking about how quantum mechanics has all these real-world applications.
Right, our smartphones, lasers, all that.
Exactly. But it also has these profound philosophical implications. It challenges our understanding of cause and effect. It suggests that consciousness might play a role in shaping reality.
It even hints at the possibility of parallel universes.
Yeah.
I mean, come on, how cool is that?
It's mind-blowing. And the thing is, we're still just scratching the surface. There's still so much we don't know about the quantum world.
So if we had to, like, sum up everything we've learned in just a few key takeaways, what would you say are the most important things for our listeners to remember?
Well, first, I think it's crucial to understand that the quantum world operates by a different set of rules than the macroscopic world we experience. Concepts like superposition, entanglement, the uncertainty principle, they might seem counterintuitive, but they've been proven time and time again through experiments.
So we have to kind of let go of our everyday intuition when we're trying to understand the quantum world.
Exactly. And second, I think it's important to remember that these quantum phenomena aren't just theoretical curiosities. They have real-world applications that are shaping our lives in profound ways.
Like we've been saying, smartphones, lasers, medical imaging, it's all based on quantum mechanics.
And as we continue to explore the potential of quantum computing, quantum cryptography, quantum sensors, we're likely to see even more transformative applications in the future.
So while quantum mechanics might seem strange and mysterious, it's also incredibly important. It's changing the world around us.
Absolutely. And finally, I think it's important to remember that quantum mechanics raises some really deep philosophical questions.
Questions about the nature of reality, the role of the observer, even the possibility of a multiverse.
Right. And I think that's what makes this field so fascinating. It forces us to confront some of the deepest mysteries of existence.
It's a reminder that the universe is full of wonder and surprise, waiting to be discovered. So as we wrap up our deep dive into the quantum world, I want to leave you, our listener, with this final thought. If the universe operates probabilistically at the quantum level, if the act of observation can influence reality, what does that mean for our own choices and the paths we take in life? Do we have more agency than we realize? Are we, in a sense, co-creators of our own reality? These are questions worth pondering as you continue your exploration of the fascinating and ever-evolving world of quantum mechanics.